All right, so I was asked if I could share some of the technical information about this project for the flying shear. I'm not going to share everything, partially because I don't have everything in a way that I can share it. I made no electrical diagrams. It's all just in my head. So I will share what I can, and then I will also describe some of the missing data because I think that's really what people are curious about. So right here in front of you is the physical inner guts of the flying shear. Roughly what we have is two motors. This motor right here, a timing belt that is connected to a rod, and that rod moves the flying shear back and forth. At the top I have some limit switches. That's to prevent the flying shear from going too far one way or the other way. It also uses it to home off the limit switch. So if you want to know how to set up limit switches in a drive, I can describe that to you in a different video or something like that. I can also teach you how to home off a limit switch. That's a good piece of information to know. It is important to note that these limit switches are normally closed, and that's because when you do limit switches, you want them to be normally closed contacts, because if the wire ever breaks, you want the system to know that there's a problem with the wiring. Okay, so that's the way they are wired. These guys, the two limit switches, come to the same motor, same drive that controls this motor, which is an M750 drive. Now, this motor is also controlled by an M750 drive. Both of these motors are model number XVM604, which means they're a metric motor. They are no longer in production. They are just some I had laying around, so I built the project around these motors. They used to make some much smaller motors than these, the XVM402s, 401s. They were tiny little 40 millimeter motors, which would have been perfect. But it is my understanding that they are looking at getting a replacement path for these motors, but I could be wrong there. That I don't really know that. But regardless, this is kind of how that works from the side. From the top, you can see there's this little thing right here. This is where the voltage controller for the light existed and the switching circuitry, which I'm not going to go into, but basically all it's doing is taking a digital output from the drive that's normally 24 volts and converting it into a 3.1 volt circuit, which drives the light that's on the bottom of this thing here. So if I continue to rotate it just a little bit, it's on the bottom of this little thing here. And this is where the conveyor belt would go across. It's an important thing to note, and maybe we should talk about this. When you're synchronizing this drive here with this drive, right? The question is, how do you go about doing that? And there's two ways to do that. The first way is you have the drive that's connected to this motor send out a synchronized simulated encoder output. So it's like a fake encoder that goes to the drive that's controlling this motor. That's not what I did. I didn't do that. What I did is I took the encoder positional data from this motor and I sent it over the Ethernet cable, okay, to the drive that was controlling this. And these motors don't have, of course, Ethernet cables. So what's basically going on is the encoder from this motor goes to a drive, and that drive now sees the position, and that position is then sent over the Ethernet cable. So the M750 drive has something called real-time motion over Ethernet, but basically all it is this cool method of being able to share data back and forth in a very quick deterministic method, and that's what I use to synchronize these two axes together. If you want a lesson on how to set up RTMoE or real-time motion over Ethernet, let me know. I can make a video on that. There is also thoughts, because someone asked about the simulated encoder output on a different question, about making a video on that. At the moment, I don't have any plans for either of them exactly at this time, but if enough pushback happens, I will definitely do so. Thank you for watching. If you enjoyed the video or found it useful, please subscribe and share the video, and I'll see you next time.